Oh, that's my second I love how you made that sound. Now it's better a lot. Okay, Ireland is both
my gosh.
and some of the
There's something wrong. Oh, I can't pick this up.
I live in a thing and there we go. Yeah, but that's like I have
Oh my god.
We'll do a couple examples and I'll change this here.
Oh. Smells like blueberries.
Blueberry.
The USD answer to that one question you.
We'll talk about it.
Are we supposed to do that?
Yeah.
What? I didn't do it.
What do you say?
We're supposed to do that thing that we did yesterday, that challenge problem.
Today we're supposed to.
No, we were supposed to do it and it's supposed to be like do it today.
I'm not done.
I don't worry about math until it's due the next period. Then I start rushing to get it done.
Matt?
Yeah.
You didn't have anything to do.
Apparently that challenge problem is due today.
Challenge problem.
Huh?
Challenge problem.
The one that we did yesterday.
I thought we were just supposed to try it in class.
Right?
You did that?
No, man.
You could get it. I feel better.
So apparently this Saturday.
I feel really good because Char's in here. He didn't
I don't have-
kind of here. I'll be
I don't
here.
have money.
Ours. That's true.
You can't all be.
What?
I mean, I have money, but I don't have it.
I was.
I don't really want to.
I'm 21.
Top 15, I thought.
Nope, top 25.
Yeah, since you didn't go, Kelly got to go.
$80 worth?
Not 25.
That would be crazy.
It's kind of meaningless, though, isn't it?
Jaden's got money.
Pretty
Worked at
It's
Mike
like
this
practicing
week,
for
loaded.
that ACT.
Well, I mean, I have
So
like,
it's what?
I have like 500, but
SAT.
I
Yeah, we've
have,
already taken the
Yeah.
ACT.
Yeah, it's actually practice for the
I have like
SAT.
500.
Nobody
The
takes
SAT.
Still have
Okay, the
to-
No, I
SAT
don't
and the
think it's
ACT
the
are the
guy.
same
No, they're
thing.
not.
Yes,
They're
I mean,
literally the same thing with a
Did you
different
get
writing.
Oh, right.
No,
I know, but the
it's
SAT doesn't have that writing.
What?
Doesn't have
Oh,
writing.
you can, I took the ACT writing.
Oh,
I
I know.
took
Okay,
I'm saying you have to.
Take a seat. Have your notes out, please, in front of you.
Right.
I need that original problem that I put on the board yesterday for the for what we were doing. We were doing that functional substitution stuff. So again, the section we're in 1.2. we're dealing with functions, and then there was a couple different topics we talked about yesterday and the days before. Let me list off everything we basically went over. We went over the different types of relations. So, that's coordinates, graphs, we went over mappings, tables, all that. Then yesterday's real focus was on domain and range. That was yesterday's focus, where we did a couple examples like doing interval notation versus, instead of roster method for listing out domain and range. One of the main little minor topics that goes with this, we talked about minimums and maximums. Now there was two types of minimums and two types of maximums. What were the names called?
Relative and absolute.
Yeah, relative and absolute. Remember, absolute is the tallest point, lowest point on a graph. There's only one of them, right? Sometimes it doesn't have to have a maximum because if it goes to infinity or something. But we use the y-axis numbers to help us out with that. Relatives is anytime your graph kind of just goes up and down and it just kind of oscillates back and forth. The peaks and valleys are relative min and maxes. Because if you were to stop the graph at certain intervals, those would be maximums at some point. Okay, if we need to, we'll go over one of those examples if you're not comfortable with that, listing those today. And then what we finished with is that last challenge question we had yesterday. Now, if you're here, you know it. It was doing evaluating functions. Functional substitutions, plugging in items into a function, spitting out answers. And it could have been anything, but I want your problem. What was the one we did? I need those three functions again. So start list them off. What functions?
G of x equals x squared minus 3x.
Okay.
H of x equals 4x minus 5. And f of x equals x plus 3x squared minus 1.
Like that?
Yeah.
Okay. So, all right. So what we had to do, what we finished with yesterday was taking one of these functions or multiple ones and plugging stuff into it, right? So one of the examples I said was do g of 2. So if there's no graph to go off of, we don't look at the graph and find 2 on the x-axis and figure out where the graph is flowing to. What we do is we just plug 2 into the g function. So I go up here and I just plug 2 into it, right? So I go, the function was x squared minus 3x. That's the g function, but I'm plugging in 2 in there. So that's 2 squared minus 3 times 2. That's what we were doing. That's what we finished with, right? But we did something a little more complicated. We did something where it was composite functions, functions inside of other functions. So this, on this particular problem, this is 4 minus 6, and that's negative 2 squared. Any questions with what we're attempting here? This is functional substitution, plugging things into the actual variables. Now, obviously, cursive is way harder than that. What was your problem?
G of f of h of x plus 1.
All right. This is our problem. It's going the most extreme end I could throw you, right? Doing functional substitutions one after another. It's literally a composite function. There's a function inside of another one, inside of another one, right? So what we do is, when I attempt to do these problems, I start the inside and work my way out of the parentheses. So I'm going to start here. I need to evaluate what that function is with x plus 1 plugged into it. So, let's get rid of the board here. All right, so what we're doing is what I'm doing right now is for that underline part, I'm doing the h function, which is this one, and I'm taking and I'm plugging in x plus 1 into all the pieces, wherever there's an x. So this is what it's basically going to look like. Right, so I still have the outer functions, but in here now, I'm taking this, and wherever there's an x, I'm plugging in an x plus 1 into that location. Does that make sense? That's the h function with x plus 1 plugged in. That's where it sits. Does everyone see that now? Okay, because here's h, plug in that into it. That's 4x on the side, right? We're going to simplify it. So that was your first step we had to do. And I think I explained the first couple steps right before the bell went off yesterday. So what you're going to have to do is you're going to have to distribute the 4, so that's 4x plus 4 minus 5. And if I simplify that, that's 4x minus 1. questions on the starting point on that? Okay, now, I'm still working, right? So I just finished one of the evaluations. I finished this one, each of whatever this is plugged in. I did that. So now, once I have this, now I'm going to start and I'm going to work with this problem now. So I still have the outside, no big deal. I still have that outside parentheses, but now I'm evaluating f with the 4x minus 1 plugged into it. So this is the f function. Now I need to plug in a 4x minus 1 into everything. Wherever there's an x, I plug in 4x minus 1 in. So this is what it's going to look like. Parentheses plus 3 parentheses squared minus 1. So that's the original f function. It's x plus 3x squared minus 1. But wherever these x's are, I'm replacing with this. 4x minus 1, 4x minus 1. Okay. Does that make sense now?
I know.
Okay. So I'm just doing the f function, and I'm plugging this little piece into all where the x's are. So I'm going to evaluate what that thing is. I'm ignoring the g for right now. So we'll get to that here in a second. So what I need to do right now is figure out what this mess is. Whatever this is simplified. I don't need the parentheses up front, so I'm just going to leave that alone. But this thing is a nightmare, this part. Because I have a 4x minus 1, I have to take it and square, right? So I have to take it times itself. That's what squaring means. And so I'm going to have to like FOIL that out, first, outer, inner, last, and whatever that answer is, then I'm going to take everything times 3. I'll distribute the 3 last. Some people try to distribute the 3 first, and you can technically get the correct answer, but if you're going to attempt that, if you're going to attempt to distribute the 3 before you start, you can only distribute the 3 to the first parenthesis. It doesn't go to all of it. Because eventually, if you go to the first parenthesis and you eventually FOIL, it eventually gets to everything. So some people try to go to everything and messes with all of it. All right. But let's FOIL it out so you can see this. So first, outer, inner, last. I'm going to just do a bunch of that in my head without multiplying by 3 here, because that's going to take a little bit. All right, so we have 4x minus 1 plus 3. Now, in this parenthesis, if I FOIL this out, that is 16x squared minus 8x plus 1. So that's doing first, outer, inner, last, because it would be 16x squared, negative 4x, and then positive 1. So that's where the 8 is coming from. And then I have the minus 1. Okay. Questions so far? Now, so far at this point, I thought personally that was pretty straightforward, getting to this point, up to this right here. Going past this point is the hard point, is the hard stuff, because we still have one more function to go. We still have to do the g function, which is still on the outside of this whole mess. So whatever this thing is going to simplify into, eventually I need to plug it into the g function. And that's why last step in g has squares in it, and that's where these huge numbers are going to come from. Okay, so distributing that 3 through that parenthesis, here's what I have so far. I have the parenthesis, that's a 4x minus 1 plus 3 times 16 is a 48, x squared. 3 times 8 is 24, negative 24x. And then 3 times the 1 is a 3, and then I have the minus 1 in there. Okay, so all I did was distribute the 3 through that parenthesis. Did I do anything wrong so far? Okay, now I need to simplify it, so then I can plug this mess into the g function. Well, simplifying this thing out, it looks like I can, the 48x squared by itself. I mean, there's only that for x squared terms. The 4 and then 24 will make negative 20 x's. The negative 1 make negative 2, and that adds with the 3 to make a positive 1. So I've simplified that mess down. So what I've finally accomplished in all of that work I've just done on the board, what this thing is, that is the f function evaluated with this thing plugged into it. That's all I've done so far. I've just plugged 4x minus 1 into that function and evaluated it down and simplified it. The last step here is to take that g function, this thing, and plug it in. So the g function is the outside. So what's my formula for g over there? X squared minus 3x, right? Is it minus or plus? Minus. All right, so notice I'm taking out the x's of the g function, and guess what I'm plugging into all these x's? This mess. This stuff is going into the g function where there's an x. So this is going to be the 48x squared minus 20x plus 1. This is going to be the 48x squared minus 20x plus 1. And now I can evaluate that. And that's where all these huge numbers come from. Because how do I evaluate this thing? Like, how do I simplify this? Yeah, how do I square it? Yeah, there's two of those parentheses. So I'm going to have to FOIL that thing out or distribute, however you want to say that. So it's 48x squared minus 20x plus 1 times itself. And that's where these big numbers come from. It's kind of saying like the type of numbers I was getting. And then back here, I'm going to distribute this 3 to the back parenthesis. And so that's minus 3 times 48. What is that? Ends with 144. X squares plus 60 x's minus 3. Now, once you distribute, you're not multiplying everything together. This is just gets distributed, and then you're going to add and subtract these things later. So that's these 3 parts. So that was kind of easy. The back is the simple part. The front is not, because I'm taking 48 times 48. Then I'm going to take the 48. So I'm going to take the 48 times each of these 3 items one at a time. So if I color code, this is what I'm doing. This is how you distribute when it's like trinomials times each other. You multiply the 48 to all 3, and then you take the negative 20 times all 3. Now, and then I'm going to take the, once I'm done with that, then I'll take the 1 times everything. So it's 3 distributions, like back, back, back. And so you're going to have 9 terms on the board if I don't simplify everything, because I mean there's literally 3 items in here, 3 items in here. There'll be 9 terms across the board, and then you eventually get to subtract these. Now I think I wrote it on a piece of paper, so I'm just going to use that something fast for the actual numbers. All right, so here's the numbers I got. So I'm multiplying that 48 times 48, 48 times the negative 20, 48 times the 1, and here's the mess I'm going to have, and I'm going to try to color code these as we go. So hopefully I don't make a mistake here. I don't know if I remember room to put this. And I'll go back over here. Enough room to write it and simplify it.
What kind of job would we do this?
This would be a business degree. You need this if you're going to analytics or business. So because you take higher level calculus in business. So, all right. So 48 times 48, that's 2,304 x to the 4. 48 times the negative 20 is negative 960 x to the 3rd, and then 48 times the 1 back is 48 x squared. All right. So there's the first distribution of those 3 terms. Then I'm going to do the middle term, right? The negative 20 times all 3 parts in the back. So negative 20 times the 48, well, that's, again, if I color code this, negative 960 x to the 3rd, plus negative 20 times negative 20 is positive 400 x squares, then negative 20 times the 1 is negative 20x. All right, so there's the blue items all distributed. And now I'm going to do the black items here. The 1 times everything in the back, which is 48x squares, negative 20x, and then 1. So I'm distributing the 1 to everything in the back. So there is all 9 items. That's just all the foiling there. And then I still have those 3 little extra pieces at the back that I haven't touched yet. The negative 144, positive 16, and negative 3. 144 x squared plus 60x minus 3. Now, if you combine like terms, the x to the 4th term is all by itself, so that's good to go. That's the 2,304 x to the 4th. The x cubes can combine. Those will make negative 1920 x cubes. If I add the x squares together, 48x squared, 400x squared, 48x squared, the negative 144, I get something like 376x squared. Double check my math. I'm doing the right one. sure about the middle term. Unsure about it. 350, that's 352. I know they have it wrong. Somebody just reminded me yesterday. All right. That was the one where I was not sure of. All right. Questions, comments, concerns. Okay, I know that's a big problem. That was like throwing you in the ocean at that point, telling you to swim across. So that was just a tough problem because we were doing those easy substitutions. Plug in a 2, plug in an x. Well, plug in other functions. Plug something that's actually worthwhile, like actually taking that and seeing how a function influences another function where you have the FOIL and all that good stuff.
What a 13-step problem.
That was good. So, all right. Now those are evaluating. Obviously, you're not gonna have something that hard. I just want to over-prepare you on that. I just thought that was a good type of problem. We will get to functional substitutions like this stuff in later sections. I believe it's not like the next section. It's like the later ones when we start doing inverse functions and stuff. We'll start doing substitutions around there because we have to double check. There's a check system why I'm bringing this up. All right. Any item from up here originally that we talked about yesterday that you weren't sure of? I know that Cassie, you weren't sure of those facilities.
Maybe that's the name.
We'll talk about that. So, okay. Other than that, you have the rest of the time to give your assignment today. It's due Friday this week. Due Friday. All right. And this will be one of the assignments on the next quarter grade. I'm going to put it over here just so I can leave them. All right. So here we go. Page 159. 134. Those problems they're asking for domain and range. Like which ones are your domain numbers, which ones are your range numbers. Those are just coordinates. You just have to list them off. It's pretty straightforward for those. What do we got? 12 through 22 even. And the big deal on those is that I do not want you to graph. So no graphing those. And it asks for like name the domain and range, right? But then it also asks you like to take that thing and graph it into a coordinate plane. I don't want you to do that. So I just want you to be able to tell me what the domain and range is for those. They usually give you sets for those, so you can kind of tell what the domain and range is. It's kind of like 1, 3, and 4, but a different setup on those. 29 through 30. What do you want to do? 55 through 59 odd. 62 so all the different pieces you're going to see, obviously those first couple are asking for domain and range. Very super simple problems. Just getting used to the notation for how you write either roster method versus interval notation. The later ones will have you looking at minimaxes, and then the later problems are evaluating things. Like plug in this item into this function, what do you get? That type of thing. So I kind of give you a range of topics. Okay, you can move around, you can sit wherever you want. You don't have a lot of time, but you can move around, you can sit wherever you need to. All right. And again, check your grade are up to date as of this moment. Make sure everything was entered, especially page 98.
Or I'm going to attempt to do this.
Are you sure?
Because, yeah.
Okay.
If
All
I
right.
need help,
Well, I have the video, so you can always watch that.
Okay.
Yeah, I mean, worry. Okay.
I have like no free time, so I want to step on one part.
All sales, you can always come in the morning.
No, my mornings are all business days. Yeah, I literally have no free time.
Hey,
I have to map stuff.
I'm gonna come in and
No, I pick up children. I babysit children from 4 to 6. I pick them up from school every day.
no, that's on Sunday, but
I literally have no free time. I babysit them from like 9 to 3. Well, it's like coming.
We're just gonna have you through that
like
one.
all at night. Come at night?
Really? It's our last
That's
time
exactly what
going
I'm
in.
planning on doing.
Alright.
We were gonna, instead of going to this progressive supper at 4, we were just gonna have
I didn't feel like going to that.
parties, because Eric's not gonna be here.
I was just planning to go to that supper.
Oh, you went back?
Yeah.
I want to come in at
Twice.
7:30. take my money back.
I remember last time I was here, we was talking about it. I've only been to
And then,
You went to Peru?
No.
Second.
Oh.
Last time I was
I say, last time I went to Peru.
If they're gone, just put them on the bottom of the stack.
Hey, Ward.
Yeah.
Didn't I give you that practice test for P1 through P4?
If it comes back to you in about 2 minutes, then you turn it back in. I'll put it in the score. No, it'll be the next one. It's not, it needs to bounce because we're almost to like a quiz. So I don't know. Just have a quiz as your first score going in there. That'd be good.
Oh, here it is. Here it is.
See, yeah, it's funny when you don't put stuff in. I really find it.
Yeah.
Here, I'll put it in this tray for you.
What day is it today? Wait, we don't pay today. It's even. Oh, it's odd. It's odd. It's odd.
We got to eat yesterday.
Yeah, so it's an odd day.
I want to know how I know.
Day 5. So
Yeah, because I ate it yesterday.
day 3 or 5. I don't
And all the girls were like, oh, let's go to Orchard. And I'm like, no, just get big and strength.
They're the even ones, right?
Spencer, there.
I'm good at archery. My problem is I can still fit through doorways. Doorways. You're not jacked yet. I need to get jacked so I can't fit through doorways. I'm gonna have to like go in sideways and.
You need to start using.
No, Jonah. That's illegal. It's illegal stuff.
That's what we're at. No, it's not.
Tyler.
Jonah, who are you, honestly? Yeah.
Now, hey, just a reminder, don't like immediately recycle these because I do make mistakes and sometimes like when I'm grading these, I forget to enter it in the grade book. Like I'm going through the scores and yours get stuck to somebody else's. I have made a mistake in the past, so don't immediately throw them away.
Whatever, doesn't matter.
I know that seems like.
How was that analysis?
I think they're very well. Was it hard? No, it wasn't hard, but I definitely didn't study.
Rookie, is this you?
Yeah.
Did you use your word bank?
See how good my
Describe this thing.
Describe those that are name those ones that act as
That are tight.
signals, you know, the odor,
Or like being.
What are you
and
doing?
the half of the separate ones, you know.
See the one
Yeah,
thing
so
that
Saturday
studies
night
the,
before.
I think it's the G protein. Describing part. Because that's like the longest one here. It's like 2 paragraphs.
Yeah.
And I'm like, I get to it, I look at it like right before the test, I'm like, yeah, I'm not gonna get this. And then for the protein package, I knew the gist of it. I understand it when it's so
It binds, changes shape, opens.
yeah.
Do we have like a day after school coming out or anything?
Next Wednesday.
What's that for?
The same stuff the teacher thing, teacher meetings.
Still in your handwriting.
I don't know if that's a good thing or a bad
It's
thing.
probably a bad thing. Actually, it means it's unique or not. Or maybe it's just that bad.
There's
Cherry system.
Jonah.
It's square.
I've been trying to do it.
It's square, man.
Nick.
Tuesday night was cool.
Thunder.
probably hit him
Oh, I already did.
hit him up on this.
I'll do that. If I I can get it to you by
No, there's
tomorrow.
one of them's open, one of them's not. I don't know, mint is okay. I only like mint in the mornings.
Both got those?
Now, are they good here or not? Oh.
Did you take pictures, please?
All the grades work except when they walk. Like squares, that kind of thing. Cube is fine, like square.
Equals no power one.
So what I would say is like anytime that, if you plug in X value, it'll only give you one Y.
Huh?
I don't know. Most of them.
So we just
Any
want,
short answer question, probably.
we just want yes or no.
Already in?
Yes.
Huh?
What there, how'd you do, John?
Yes or yes.
Anthony, the back.
Yes,
only 26
yes,
points.
no, no.
This is a little
Big
tough.
hires.
No, it's stupid.
Wikipedia.
Which is stupid because
Sounds great.
you can have like 5 ag classes, study halls, and like maybe your core classes can get in top 25. Whereas you got someone who's taking actually like upper level classes, not in the top 25. It doesn't, it honestly doesn't.
Is it like your rank of grades?
Yeah.
Yeah, well, yeah.
Kind of what you scores.
I'm 30.
Grades.
Hi, what are you?
33.
What's your major?
I don't know where. Last time I checked, it was like writing.
Algebra is super really stupid.
Oh yeah. So bad.
Yeah.
Where do you make things easier than Gavin does?
Yeah.
Much.
Because I got
Not
two
that
grade
hard
in
to
algebra
do,
too.
but.
I used to be really good math until I took this class.
PreCalculus.
Did I bring you down? Did I bring you down?
No, like Word or Johnny class. Alright, 29.
I thought you were saying that I brought you down.
Or do you have class time tomorrow or something?
A little bit. Not very much.
What did you say?
You will get some time because it's due Friday, so.
I know, right? I work every night and I get my homework in on time and I still have to surgery.
But I don't.
Shots fired. What do you do every night? Play?
Yeah.
Play practice? That doesn't count.
Why?
Yeah. That's not real. It's like a draft.
Alright, what do you do every day?
Work.
That's right there.
That's why I struggle so much.
You got your sisters in play.
Remember then told my dad to get your homework on work one. I was 16 years old. 16 years old.
Same for me. Do homework. I have fun.
I love money and everything.
Have fun at work. Why not both?
Yes, Razor is, what's his name still there?
No.
He's not. He was the most chill guy. He should have been with us that day.
He came in earlier that night. What time were you?
Really?
Yeah. Everyone came in and saw me.
He should have been with a bunch of his manager is temporary there. He left all the people behind me.
Oh, he let everyone come behind the counter and...
Was that like?
Huh?
We lost to them a couple weeks ago. Probably because like
It was pretty good. All we were jamming out to great.
everyone
He's like,
Yeah.
okay, I was scheduled 4 to 11 that
Here's
night.
another way to do it. You graph it.
Or two
I'm
about
like,
Saturday.
He's like,
We're gonna
if
be
you
good.
want to leave the
From
building,
bring-
that's fine with
Google
me.
type it in.
And I'm like, what? Why? And he goes, because where I work, everyone
There's
doesn't
another
go
way
to
to
work,
type it.
and I
You
have to
like
go
that
anyways,
answer.
so I send them home early. And I'm like, no, I'm staying till 11 and getting all my stuff out, so you don't have to do anything. Did everything, and I was done. He went to check me, and he was like, oh, I hate you. And I go, why? Because you didn't leave me anything to do. I'm like, same.
I'll try it.
He's so good. From Minnesota, he doesn't fish. That's a very good.
He's like,
But Minnesota's a resort.
he's like me a lot.
Oh, I see.
not remember getting left at Wendy
Yes, I remember getting left at Wendy's.
and walking up to the wrong band?
Oh, because I already thought it was your van. So I need friends.
You need new friends every year.
No, I wouldn't do getting new friends.
Okay, who are you gonna be friends with?
No one.
Actually, I think it's chilly.
Honestly, we were dying laughing though because
We were
went
just
around.
following you as you're walking up to this van, and we're just like right beside you. Takes you like a good 15 seconds, you look over, you're like,
You were just about to get in that other van too. I should have let you. That would have been so funny. Like you opened up the door. And
No, I wasn't walking towards the van.
Yes, you were, sir. You were walking towards the
I was
van.
standing.
You were walking.
I was standing.
we were
Sir,
walking.
I- we were creeping.
We were right behind you, we were creeping. Because we couldn't along the location.
You weren't standing because if I would have put the van in park, you would have still gone.
This is my wish.
We should have.
I wish I moved in this.
Why? So you can get left at Wendy's tomorrow?
No, because I was gonna move in like what?
Actually, your parents are gonna move.
No.
Yeah.
My all.
Your parents are gonna move.
Yeah. Okay, my parents are gonna move. They're going to be here.
Yeah. They're gonna move with you. You're not moving.
What are you talking about?
You were gonna move in first grade? No, your parents were.
You have no say in that process.
Yeah. First grade mind isn't gonna do anything to change their reasoning of moving to Minnesota.
What's your dad's name?
My father? Christopher.
How your dad?
Are you really?
Oh, not now.
Nothing I'm familiar with. Could be a different order.
That works in my truck?
I need new friends.
I thought maybe your dad.
Your sibling?
No, my brother.
Oh, I'm sorry. You look like your dad's age, though.
My bro? My Connor, you got your papers. Whoever's in the next class.
They can use them if they're missing assignments. Just put their name on them. Oh wait, they've got grades on them.
And make sure that I enter this for